Okay, welcome back. And today we're going to talk about in a few examples of identifying domains, ranges, and functions, whether these are function or not. So we're going to look at the algebraic expressions, and these also we can call these the rules, right? These are the rules. Algebraic expressions can be looked at as rules that define the relationship between x and y, the independent variable and the dependent variable. But not all algebraic expressions like these are functions, okay? So what we're going to do is we're going to go through each one of these and determine the domain and range and whether it's a function or not. Okay, not necessarily in that order, but we'll talk about all three of those aspects for each one of these. So the first thing we look at is y equals x plus 4. So if we look at this and we see, okay, the rule says whatever value of x we put in here, we're just going to add 4 to it. And that's going to be our value of y. So we ask ourselves, okay, for every value of x, is there exactly one y? And the answer is yes, right? You're not going to get two values of y for one value of x. So this is going to be a function, okay? So for every value of x we put in here, we're only going to get exactly one value of y. So this represents a function, okay? So this is a function. Okay, now, the domain. Okay, well, remember what the domain is. The domain is all values, all the real numbers of the independent variable x that will give us a real value, a real number in y. Okay, so in this case here, are there any values of x that will not give us a value of y? And the answer is no. Okay, remember this is a straight line, right? So this is a linear equation here, so this is a straight line, so there are no values of x that won't give us a value of y. So the domain, in this case, is all real numbers. So it's going to be negative infinity to positive infinity. Now likewise, the range is also all real numbers. Okay, so these are all the values of x, and remember the range are all the values of y. Okay, now what about b here? Okay, so b, first of all, let's see if this is a function. Okay, so for every value of x that we stick in here, is there exactly one value of y? So if we stick in 1 in here, y is going to be 1, and so on. So again, we can easily see that for every value of x, we will get exactly one value of y. Now again, one of the things we have to look at is we can't have negative numbers under the radical, but again, that's part of the next question on the domain. All we care about now is, hey, is there a correspondence that says for every value of x that we stick in, we only get exactly one value of y? And the answer for this is yes. This is a function. So this is a function here. Okay? Now, domain and range. So let's look at the domain. Now the domain, remember, the domain is only real numbers of x that will give us a real number in y. So we can't have, since we have an even root here, we have a square root, we can't have any values of x that will make this radicand negative. So again, I'm going to solve this inequality. We only want the values of this radicand that are equal to or greater than 0. So we're going to say, I want only the values where this expression is greater than or equal to 0. Well, that's going to be true if x is greater than or equal to 1/2. So guess what? That's the domain. So the domain is going to be everything that's greater than or equal to 1/2. So that's going to be the interval from 1/2 to positive infinity. And remember the square bracket because it's greater than or equal to. Okay, now, what's the range of the value? Okay, so what happens to y? Okay, so as x goes to 1/2, so when x is 1/2, this is 0. And then as x gets bigger, well, what's happening to y? Well, y is also getting bigger. So in this case here, what's the smallest value that y can be? Well, y is going to be 0 when x is what? 1/2. And then as x gets bigger, y is going to be positive and getting bigger as well. So now, so the range in this case goes from 0 to positive infinity. Okay? So again, just look at these three things. Okay, now let's look at C. Now C has the expression y squared equals x. So let's start with deciding whether this is a function or not. So the first thing I'm going to ask is, okay, again, for every value of x, is there only one value of y? Well, here, we've got this y squared, so let's look at, let's stick a number in here. Let's pick a perfect square. Doesn't matter, any perfect square. Let's look at 16. Right? Let's look at 16 equal to x. Okay? What y value squared will give you 16? Well, 4. 4 squared equals 16. But there's also another value that will also give me 16. That will be -4 squared. Okay? So 4 or -4, if I square it, will give me 16. So that means that if x is 16, right? If x is 16, what two values of y squared will give me 16? Well, 4 and -4 will both do it. So that means that there are two values of y. So I can have 16 comma 4 or 16 comma -4. So in this case here, I've got one x value, but I've got two y values that correspond to the same x value. So this is not a function. Remember the definition of a function when we were looking at that. Ordered pairs, right? If I have the same x value but different y values, it's not a function. Okay? So this is not a function. And all you have to do is come up with an example that works, like this one. And again, that's not the only one. You could have used any perfect square. So this is not a function. Okay, now the domain. Okay, let's look at the domain and range. Okay, so now the domain. What values of x can I put in here that will give me a value of y? Well, let's think about this for a second. Are there any values of x that will not give me a value of y? Well, in this case, what about negative numbers? Well, let's do -1. Okay, what if x is equal to -1? Is there a value y that I can square that will give me -1? Can I stick any y value in here and square it that will give me a negative number? No. No, there's no such y value. So for negative 1, there's no y value that I can put in here that will give me a negative 1. So there's no y value that corresponds to x equals negative 1. In fact, there's no negative, so it doesn't matter if it's any negative number. Okay? Now, if I put in 0, right? If I use 0, right? And I say, okay, is there a y value that I can square that will give me x? Well, yes. Y equals 0. We'll do it. Okay? Or what about this? What if I have, let's say, 2? Well, is there a corresponding y value where y squared will equal 2? Well, so is there a y value? Is there something squared that will also give me 2? Well, in this case, it's going to be the square root of 2, right? Okay? So in this case here, when we look at the domain, it has to be what? Greater than or equal to, it has to be a positive number. And so in this case here, 0 will work. So 0, it has to be a non-negative number, right? So 0 will work. Or any positive value of x will work. Now in this case here, again, because it's not a function we don't have to worry about, but when we take the square root, we have to have plus or minus. So, but the point is hey, is there a value of y that corresponds to value of x? And so any of those real numbers will be in the domain. So guess what? The domain, again, are all the x values. So again, we're not focusing on y values, we just want to make sure, are there any restrictions? So in this case here, the domain is going to be all x values from 0 to positive infinity. Okay? Can't have any negative values for x. Now the range. Okay, now the range, as we start with 0, right, it goes from 0, right? So when y is 0, but as x gets bigger, positive, y is also getting bigger, positive, but remember, there's a plus or minus to this, okay? So remember, if I take the square root of both sides, y equals plus or minus the square root of x. So that means y is going to have a plus or minus. So as x gets bigger, y is also getting bigger, but getting bigger positive with a corresponding bigger negative. So the range, in this case, is x gets bigger, the range is going from 0, right? Starting at 0, but it's going out, it's spreading out both up and down. So the range is starting here, but it's spanning out this way and this way. So that means the range is going to be from negative infinity, positive infinity. Okay? Okay, so now let's look at this one. Now this is an inequality, okay? So now, remember about inequalities. Inequalities, you're talking about if you put one x value in here, is there only one y value? So for every x value, there's exactly one y value. Okay? So if we just do a real quick example here. So let's just put 1. Right? So in this case here, we have 1 minus 1. So y is less than or equal to 0. So how many y values are there that satisfy that are less than or equal to 0? Well, an infinite number, right? So for one x value, you have an infinite number of y values that satisfies this inequality. So this is not a function. In fact, all inequalities are not automatically not functions because of this reason. You're talking about an inequality. So you'll always have a range of values, okay, that satisfy that. In some cases, I mean, in most cases, I would say, you know, you could come up with an example where it'd be exactly, but for general purposes, inequalities are not functions. Okay, so this is not a function. And so now what's the range of this thing? Well, the range of this thing is going to be all real numbers for both. Okay, because again, there's no value, because it's sort of like this one, it's a linear, for every x value, you're just subtracting 1. So this is going to have a range of all real numbers and a domain of all real numbers. So the domain is negative infinity to positive infinity. The range is also the same thing. Okay? But this is not a function. Okay, and now the final one, now we're dealing with a rational expression. Okay, so now, is this a function? So now, again, let's go back to the definition. For every x value we stick in here, is there exactly one y value? Again, we don't care about restricted values at this point. So we'll focus on the denominator in a minute. But if I stick in an x value in here, do I get a corresponding exactly one? So in other words, do I get, if I want to make sure that I don't get more than one value of y. That's the ticket. Okay. So if I stick in 2 here, do I get exactly one value of y? And the answer is yes. Okay, because if I stick in 2 here, y is 5. If I stick 3 in here, I get 5 halves. If I stick 3 in here, I get 4 in here, I get 5 thirds, and so on. So in this case here, there is only one y value for every x value that I stick in here. So this is a function. Okay, now the domain. So the domain, now this is where we have to be careful, right? So this is where we're looking at a rational expression and we want to make sure, again, the domain is all real numbers that will result in a real number for y. So when we're talking about rational expressions, we cannot divide by 0. So any value of x that makes this denominator 0 is not in the domain. So we call that a restricted value. So we need to find out when it's equal to 0. So one way is just set it equal to 0. When is the denominator equal to 0? Well, we can set it equal to 0, right? And then we find that x equals 1. So that means x equal to 1 is a restricted value. So that means anything else is okay. So that means that the domain is all real numbers except x equal to 2. And the way we would do that is we would say that the domain is, we could do set builder notation. We could say all x such that x is not equal to 1. And that's the domain. So the domain is all real numbers, all values of x, such that x is not equal to 1. Okay? Now, if you use interval notation, you could go, well, and this is again a little bit sloppy. I like set builder notation in this case here. But what you could do is in interval notation, you would have to write, well, everything from negative infinity to 1, and then union everything from 1 to positive infinity. Okay? So this includes everything except 1. 1 is not included, but I like this way better. It's more concise and succinct. Okay? Now, What about the range? So the range, again, is all the values that come out. So as long as x is not 1, then I will get a corresponding y value that goes, well, so what, well, let's think. So let's go from 1, okay? As I get closer and closer to 1 from the left, right? So I'm going negative, right? So negative, I go to 0, and as I'm getting closer and closer to 1 on the left side, so let's say 0, 0.5, 0.75, well, what's happening to this denominator here? As I'm getting closer and closer to 1, this denominator is getting closer and closer to 0. And as a fraction, as the bottom gets closer and closer to 0, and this is staying the same, then the number is getting bigger. And if you want to see this, just take an example. So if I take 5 over 1, that's equal to 5. If I go 5 over 0.5, so I'm cutting the denominator in half, well, that equals 10. Okay? And if I cut the denominator in half again, I take 5 divided by 0.25, well, now it's going to be 20. Okay? And so every time I cut the denominator in half, the number is doubling. Okay? So you can see as the denominator gets smaller, the value of y is getting bigger. Now, what if I stick in negative numbers? What if I go to the other side, right? What if I go to the other side of 1? So in this case here, if I'm getting closer and closer to 0 here, so what's happening here? Well, if I get smaller, I'm going to get a negative number here, right? So this is getting closer to 0, right? But, for example, 0.5 minus 1 is negative 0.5. And then if I do minus 0.25 or 0.75, it's getting negative, but it's getting less negative. Okay? But it's still negative. That's the point. So as I'm getting closer and closer to 1 on the left, this thing is negative, but it's getting closer to 0, but the whole thing is getting bigger, but negative. So this is going to negative infinity. Now if I go on the other side, if I approach 1 on the other side, so this is where I'm talking about, now instead of the left side, now I'm going to approach 1 from the right, which is, we're going to go, let's say 1.75, 1.5, 1.25, and so now I'm getting closer and closer to 1, but from the other side of 1. Now, this thing is still getting closer to 0, but now what's the difference? 1.75 minus 1 is positive. 1.5 minus 1 is positive. So these are all positive, but now it's getting close to 0, but positive, and so now y is getting bigger, but it's positive. So it's going to positive infinity. So the range turns out to be from negative infinity to positive infinity. Okay? So that's the one you kind of have to watch out for when you're talking about rational expressions and you're talking about the domain and the range. You've got to kind of think about, hey, how am I approaching these things? We're going to get to this a little bit later when we talk about graphing these types of expressions, these types of equations. But for right now, just you got to think about, hey, what's happening to the value of this thing, positive or negative, as x gets closer to a certain number. Okay? So in this case here, it goes from negative infinity to positive infinity. Okay? So the domain is all real numbers except x equal to 1. And the range is all real numbers. Okay, and that's it.